productive and whatever, it might as well be see-through. Like my genie in a bottle, bitch can get me rich, look like a magazine model. Before you know it, he have her on a stroll, fresh and ripe, complexion like Acapulco gold. If I had to guess just...
How's it going, guys? Today I want to go over a question called Decode Ways. This is a question that's being asked by Facebook right now, so good question to know. It says, a message containing letters from A to Z is being encoded to numbers using the following mapping. A maps to 1, B maps to 2, C maps to 3, so on and so forth, and Z maps to 26. So it says, given a non-empty string containing only digits, determine the total number of ways to decode it. So just as a quick example, if we're given the string 1, 2, there are 2 ways to decode it, so we output 2. And the reason for this is it could be either decoded as AB, which is 1 and then 2, or L, which is simply 12. This is a common dynamic programming question, or at least it's modeled as one. I feel like this is typically this can basically be disguised as like a climb stairs problem, I feel. So it's kind of like a variant of your typical dynamic programming question you might see, or one of them. And we're going to solve this by using something called bottom-up processing. It sounds really scary, it sounds really complicated, but basically all it's saying is if you're asked to determine how many ways there are to decode a string of length n, you're just going to use all the sub-problems up until n to actually solve the problem. So what we do is we start with a base case and we determine what the answer to the base case is, and then we build from those base cases and eventually solve the problem for n. So let's do that now. So what we're going to do is we're going to make a dynamic programming array. So we'll say int dp equals new int s.length plus 1, and the reason why we're saying plus 1 here is just because we actually want to account for the number 0, right, if we have no string, and then we also want to return really the length, or the number of ways to decode a string if it's of the length s. So we want to make sure we include plus 1. So now we're getting to our base case. So we said we're going to use all our sub-problems to solve the larger problem that we're actually asked. So we want to start with our base case. So our base case here is just going to be if we have a length of 0, right? So if dp of 0, what's that going to equal? It's going to be 1. And so just to make sure I'm explaining this correctly, dp is going to store the number of ways to decode a string of length x or y, right? So dp of 0 really represents the number of ways to decode a string of length 0, which is 1 because there's really no way to decode an empty string. Now, similarly, we could just say dp of 1 is also equal to 1. Sorry, that's wrong. dp of 1 is going to depend on what the value of the first character is. So if we look at our mapping again, a maps to 1, right? So we actually don't have a mapping for 0. So the only thing we need to pay attention to is if our first character is 0 or not. So we could say s.char at 0, and if that's equal to a 0, then we don't want to have anything. We say there's no ways to decode it, right? Because we actually don't have a mapping for 0, and otherwise, if it's anything else, it's going to have a mapping, or one way to decode it. So now we have those 2 base cases, really, right? We said the number of ways to decode a string of length 0 is 1, and the number of ways to decode a string of length 1 is going to depend whether or not it's a 0. So now we could just iterate all the way up till s's length. So we'll say for int I equals 2, because we already solved the subproblem 0 and the subproblem 1, while I is less than or equal to s.length. And again, this is because we want to know for s's length, right? We want to include s's length. We don't want to get cut short. So now at every situation, we want to use our subproblems, right? So the first thing we want to do is actually evaluate the digit we're on. So we're going to look and evaluate the digit we're on. So let's do that. So we're going to say int, and we'll say 1 digit equals integer.value of, and we're going to say s.substring of I minus 1 up till I. So all I'm doing here, this integer.value of, seems a little complicated, but all we're doing really is we're getting the substring of the current character. So we're just getting the current character we're on, converting it to an integer, and now we have it stored in 1 digit. And now the next thing we want to do is we want to get the last 2 digits, or the current digit and the previous digit. And the reason for that is because our mapping only goes up to 26, right? So it has to be between 1 and 26, so that's why we're getting 1 digit and 2 digits, because 3 digits doesn't matter, right? We can't have a mapping that's 3 digits long. So now let's get our second digit. So we'll say int 2 digits and we'll say integer.value of s.substring of I minus 2 up to I. So again, it's the same exact thing. We're just getting the last 2 digits now, or the current digit and the previous digit combined together and turned into an integer. So now what we want to do is we just want to check, do these things have mappings, right? So if one digit is greater than or equal to 1, then we know there exists a mapping. So we want to add to the current subproblem that we're trying to solve all the possible ways to decode the previous digits, which will be represented as the maximum ways of decoding those digits, right? Which is conveniently our DP array. So we'll add to our current subproblem the answer to the previous subproblem. And now we want to do the same thing but for 2 digits, right? But we need to specify something different now, right? We need to make sure it's greater than or equal to 10 and also less than or equal to 26. So we'll say if 2 digits is greater than or equal to 10 and 2 digits is less than or equal to 26, then we know it has a mapping. So we can add to the current subproblem dp of I minus 2. So guys, it's really as simple as that. So now once we actually have filled our entire DP array up till the end, all we need to do is return dp of s.length. And remember, the reason why that will work is because our DP array stores the maximum number of ways to decode the string up till that index. And the index represents the number of characters we have. So this is going to represent, in the end, the number of ways to decode a string of length s, or s's length in this case. So let's make sure that this works. Awesome, and it does. So guys, that was using bottom-up processing to solve the LeetCode question Decode Ways. If this was helpful and helped you understand dynamic programming, do me a favor, give me a thumbs up. I actually ended up doing this question because someone in my Discord channel asked me to do it and throw in a DP problem. So if you guys are interested in joining that channel, that Discord server, I'll leave a link in the description. Yeah, if you guys enjoyed the video, leave it a like and subscribe, and I'll see you guys next time.
If you broke though, kept a shorty mad, finding much thinner. If caught, I get mad time just for touching her. Not wood, so much for Hymens. So fly, she should be in the sky with diamonds. Little young thing, she like to do the tongue thing. At times she